adding the second dimension to this means that we're going to have to do more than just have pluses and minuses to take into account the direction. We're going to have to really think about this in terms of the triangles, the vectors, and how they kind of map out. The picture describes what's kind of happening. Two kids are pulling a crate across an alley. There's no friction, so this problem says there's no friction acting between the crate and the ground. Maybe it's on a pulley system or something, like wheels that are frictionless. But basically, we want to know what's the net force on this. And we can't really assume that this thing is going to follow that dotted line. We don't know which direction it's going to go. We have to add the vectors up to see what the net force is. So when we go to do that, when we want to add the forces, right now they're shown with the base of the vectors added together. What we need to do is place them so that they are added tip to tail, like we talked about before. So this is the first force, and this is the second force. And when we do that, we can then see that this vector over here is going to be the net force. Okay, so just making it a little clearer, we can see that this is F1, this is equal to F2, and this will be, the addition of the two will be the net force. All right, and that's what we're going to do. Now, you can solve this using the sine law, cosine law. In fact, I think that given we know this 30 degrees, we know 30 degrees and 20 degrees here, we can probably figure out the, I don't know, figure out this angle. We know that F1 is equal to 150. We know that newtons. We know that F2 is equal to 110. Newtons. So we could do, like we've got two sides and the interior angle. I'm sure this can be solved using the cosine law. But I actually just think that's hard. So we're not going to use that method in this problem. I'm going to try to show you another way that will make it a little more clear. And that is using components. So first thing we want to do is find the components. So I'll put it here. Number one, what we're going to do is find the components of each vector. And then what this looks like is this. We can see that for vector 1, force 1, it's partially being pulled north and partially being pulled east. So what we're going to do is we're going to draw this vector. Actually, let me show you this off to the side. So here is the first vector. That's the first one. It's not showing up. Hang on. Command S. Okay, there's the first vector. And you can see it's identical. This vector is identical to the F1. It's in the same, it's pointing in the same direction. It's the same length. So what we're going to do is say that that is equal to, it has an X component and a Y component, just like we talked about before when we talked about velocity vectors. Now we're talking about force vectors, but the idea is still the same. These components still represent the same idea. So now what we can say is with F1, which is 150 newtons, we can say that this is F1x and this is F1y. This angle here, they tell us, is 30 degrees. So we can solve this. We can say that F1y, let's do x first, equals 150 cosine of 30. And that equals, 150 cosine, let's do it over here. That equals 129.9. Oops, 0.9. Newtons. Okay. And then F1y equals 150 sine of 30, and that equals 75. Okay, so that's the components. That's their value. And if I vector add F1x, the green vector, plus F1y, the orange vector, I get the resultant. But I've just broken them up in the components so that we can figure them out. Now let's figure out the second one, which is this one. Let's see, sorry. This vector is F2, and it's pointed down, same size, same direction. We're gonna take this and do the same thing. We're gonna find the X. You can see that's, let me put it up there. Oops. That's the X component. Let me do that. And then the Y component, now you can see that it's pointed down this time, right? So it's not pointed up like the other one was, but this time it's pointed downward. So that orange vector is pointed downward. But what we have here is, this is F2X, this is F2Y, and then this is just, well, I'll put here, like I said here, it was 110 newtons, and then the angle is 20 degrees, and it's below. Which is why it's negative. Okay, so then doing the same thing we just did, we're going to say F2x is equal to 110 cosine of 20 degrees, and that equals 103.366 newtons. And then F2y equals 110 sine of 20 degrees equals 37.622. 37.622 newtons. Okay, so now we have all of our information. We have all the things we need to do. We found the components. Now what we need to do is find, we have to basically, so this is what I want to say. What I'm trying to tell you is that the vector addition of the if I take the component of the first one, so if I take the component of F1 and add it to the X component of F2, like let's do the X component of X2, and then I take the Y component of X1, and I subtract, because it's pointed down, the Y component of F2. I hope I'm saying all that right. We end up with the net force. So basically what you're doing is, you see, that goes right there. So zooming in here, this is my net force, F net. This is my F1x, my F2x. The upward pointing one is my F1y, and this downward pointing one is F2y. So if I add the components of each, then I get the X and Y components of the net force. So let's do that math. Here, let me move this up a little. Let's do that math, and we can see where it takes us. Okay, so now we're going to find that. So what we're going to do is two separate equations here. We're going to say F net X is equal to, all I have to do is add up the two X components, which are over there. So I'm going to let's say I'm going to add this one and this one, right? So F net X is equal to F1X plus F2X, which equals 129.9 plus, and it's plus because they're both pointing in the same direction, the two green arrows, 103.366. Add all those up together, and I get 233.27 newtons. Okay, great. Now F net Y. F net Y equals, and now these are what I'm adding up, the 75 and the that. So I'm going to say this is equal to F1Y plus plus is not what I want to do. I actually want to subtract because it's in the opposite direction to Y. I mean, you could also say plus negative F2Y. It's the same thing effectively, right? So then we're going to put in here 75, let's see, Y, 75 minus 37.622, and that equals 37.3777, 37.3777. Okay, So we've got this, newtons. So now we have the components of F net X and F net Y. So what I want to do here, I'm going to do this here, is I'm going to say, well, this is, let's see, I can do this like this. I'm going to take those and I'm going to show you the kind of the new triangle we've got here. So this is, again, my F net, same direction as every time you see that blue arrow, it's the same thing. But this is just F net in the Y direction, which we got from subtracting those blue arrows, those blue numbers. And then this is just F net in the X direction, which we got from adding the orange, the pink numbers. I'm talking about the highlighted numbers here. Okay, so having found that, let us go to say, how do we actually find out what F net is? Well, now it's just a Pythagoras question. Let me actually, instead of putting F net Y and F net X here, I'm just going to put the numbers to make it a little easier. This is 233.27 newtons. This is 37.3777 newtons. It's still up because it's like the person pulling sort of in the northeasterly direction pulled like upwards harder than the person pulling in the southeasterly, pulled harder than the southeasterly one. Okay, so this is just a simple case of Pythagoras. So then F net equals the square root of, so the two values, 233.27 squared plus 37.3777 squared. And then that answer comes out to F net equals 236.25 newtons, 0.25 newtons. So that's one of the things we need in our answer. I'm going to put a circle around it so you know that's kind of the magnitude of the net force is this. But what the question asked us for the magnitude and the direction. So what we also have to find that's really important to this question is the theta. This is theta. It's tiny. It's right there. So what is theta in this case and how do we find it? Well, you can see that what we have is theta. For theta, we have the opposite and we have the adjacent. So what we're going to do is use the tangent. So stay with me here. We know that the tangent of theta is equal to, and it's going to be opposite, which is 37.3777, divided by 233.27. And then how do you solve this? This is something that some of you were having trouble with in class, but tan theta, just dividing those two numbers, we get 0.61602. So then theta, I don't know how you want to write it. It's either arctangent or tan inverse of that number. It's basically second function tan on your, what you're doing here is second function, second tan. And then you get and you put in the number. And then when you do that, you find that theta equals 9.1 degrees. And that is the other part of the solution. Okay, so how do you put it all together? Finding the final answer in this question. For the final answer, let me pull this back here. The final answer is, let's see, final answer. So in the final form, you're going to say that the net force is, and the value is 236 point, well, I guess with significant figures, we can just leave it like that, newtons. But now we have to translate that theta into a direction. And if you recall, if we look at this little thing here, recall that our direction, according to the question, is like this: north, south, west, east. So you can see that this force is pointed mostly east, but a little bit north of east. How much north of east? 9 degrees north of east. So you could say the net force is 236 north. We're going to use these square brackets to denote the direction. And we could say 9 degrees north of east. Another way to write it is east 9 degrees north. I think there's probably some nautical way you could write it. I would accept that too if you're into that. But that's essentially the answer. The net force, so this is your final answer. The net force is this, and that's how we get it. A lot in this question. Please bring any questions or difficulties you had understanding it to class, and we will go over it together. Thanks.